Mr. Moore's math class!
Good afternoon, guys, and welcome to Mr. Moore's online flipped classroom. Now, like always, we have got plenty to get through today. We're going to be learning all about how to use the discriminant to determine the number of x-intercepts that you can find when sketching quadratic graphs. Now, there's a few things that you need to be able to know in order to be able to do this. So let's have a look at a bit of an explanation that I've prepared earlier.
Alright, so we're looking at the discriminant now, and as you can see, the formula for this, that is the discriminant, is equal to b squared minus 4ac, where discriminant is represented by the triangle. Now what this actually tells us is the number of solutions that there is for a quadratic. Now by that we generally mean the number of x-intercepts. Now some of you are actually probably looking at this thinking it looks a little bit familiar, that is, you've seen b squared minus 4ac before. Well, you actually have, because it comes from the quadratic formula that you can see here. So in the past what we've done is we've used a quadratic formula to find out whereabouts the x-intercepts are, but sometimes there might not be any, so we might want to actually check that out by using the discriminant first, because it could save us some time. Because as you probably found out, when you substitute into the quadratic formula and simplify, this takes a little bit of time. Now why would you even bother if you could figure out that there's no solutions in the first place? And this is exactly what the discriminant does. Now, in the case where you get a negative answer for the discriminant, we know that if we actually substituted this negative answer into the quadratic formula, that we'd have to square root a negative. Now, of course, we know that we can't do this, because when we put that into a calculator, it freaks out and says things like no solutions, for example. But really, what's actually occurring is you're actually getting graphs that look like the ones that you can see here, where they actually do not cross the x-axis at all, and that's why there's no solutions, because there's no x-intercepts. Now in the case where the discriminant is equal to 0, what you're going to do when you square root 0 is get plus or minus 0. So in this case you only get one solution of negative b on 2a that you can see here. And for functions where the discriminant is equal to 0, what you're going to get is graphs that look like these, that is where the turning point is actually right on the x-axis, giving us only one x-intercept. Now in the case where the discriminant is positive, we can actually square root positive numbers. So when it comes time to having done this, we can add and subtract a number from b. This will actually give us two x-intercepts, or two solutions, as you can see here. So summing up, the discriminant basically tells us the number of x-intercepts or solutions that we can find for any given quadratic function. Now remember, this comes from the quadratic formula that you can see here. So when dealing with the quadratic formula, or with the discriminant as well, what we do is we get the a from the number out the front of the x squared, the b from the number out the front of the x, and our c is our constant. Okay, so we're going to learn all about the discriminant today, and there's a few things that we must know. The first one being the formula. Now the formula for the discriminant is triangle is equal to b squared subtract 4ac. That is, the discriminant is equal to b squared subtract 4ac, where you've got an equation 0 is equal to ax squared plus bx plus c, where your a value is the number out the front of the x squared, the b value is the number out the front of the x, and the c value is the number at the end, or the constant. Now if you would all think this looks familiar, well it actually is in fact, because it does, because we know that for the quadratic formula you've got x is equal to negative b plus or minus the square root of b squared subtract 4ac over 2a. And of course, as you can see here, the b squared subtract 4ac is exactly the same as what we've got here for the discriminant. And this leads us to ask the question, well, what does the discriminant actually do? Well, we need to use the discriminant to figure out how many solutions, or in other words, x-intercepts there are actually in any equation. So what you can see here is we've got three axes that I'm building, and we've got quadratic functions. Now this quadratic function here is just going to go down like that. This quadratic function is going to come down, just touch the x-axis, and this one's going to come down and go all the way through twice. Now what you can see here is this one doesn't touch the x-axis at all. Alright, so what we get here is if the discriminant is less than 0, then there are no solutions. Whereas if the discriminant is equal to 0, there is just one solution. That is, you can see it just touches here. And if the discriminant is greater than 0, we have two solutions. That is, it goes through the x-axis twice, here and here.
Haha, now I see. So the discriminant actually comes from the quadratic formula. Alright, now let's check out a couple of worked examples on how to actually apply this. Let's go.
Alright, so let's have a look at a worked example for this. Now it says find the discriminant for the following. That is, for A, 0 is equal to 3x squared plus 2x minus 7, and B, 0 is equal to x squared minus 4x plus 10. So the very first thing we need to do is we need to go through and label our A, B and C value. So you can see here is our A value, we can see here is our B, and this is our C value. And we'll draw a circle around just to make it really clear, shall we? Right, now the formula for the discriminant is equal to b squared subtract 4ac. Alright, so let's go through and substitute all of the values in now. So you get the discriminant here is equal to b squared, well that's going to be 2 squared, subtract 4 times a is 3, times negative 7 for c value. So then we get 2 squared is 4, minus 4 times 3 is 12, times negative 7 is negative 84, so it's going to be negative 84, and we end up getting 4 minus 84 becomes 4 plus 84, which of course is 88. Alright, now it's time for you to press pause and have a go at the following question, that is 0 is equal to x squared minus 4x plus 10. Remember to press play once you're done so you can check your solutions against mine. Alright, so welcome back. Now what you can see here is we've got our equation 0 is equal to x squared minus 4x plus 10. Of course the very first thing we need to do is go through and write out our a, b and c values. So we'll go a value here, b value here, and c value here. Now our a value is the number out the front of the x squared, and there's nothing out the front, so what that means is that's actually a 1. Right, our b value is the number out the front of the x, so we've got a negative 4 there, and our c value is positive 10. So write out the equation now for the discriminant. You've got discriminant is equal to b squared subtract 4ac, and of course b is equal to negative 4, so you get negative 4 squared, minus 4 times a is 1, times c is 10. Now what we need to do is go through and simplify that. So you've got negative 4 squared is 16, because negative 4 times negative 4 is positive 16. And you've got 4 times 1 is 4, times 10 is 40, so you're going to minus 40, so 16 minus 40 is negative 24. So in this worked example it says find the number of solutions for the following. That is, you've got 0 is equal to 5x squared minus 9x plus 4, 0 is equal to 4x squared plus 4x plus 1, and 0 is equal to 3x squared plus 2x plus 10. Now, the question is saying basically how many x-intercepts are there going to be? Alright, so what we need to do is we're going to actually go through and find the discriminant for these, but then we're going to need to interpret our answer. So let's go through and do the first one, shall we? Let's go through and first of all we need to find out our a, our b and our c values. So we've got our a value is here, our b value is here, and our c value is here. So that means our a value is 5, our b value is negative 9, and our c value is positive 4. Let's go through and write out the formula now. So we've got the discriminant is equal to b squared subtract 4ac, and of course we'll go through now and substitute in. So we've got discriminant is equal to b squared, so that is negative 9 squared, subtract 4 times a is 5, times c is 4. Go through and simplify that now. Negative 9 squared becomes positive 81. Subtract 4 times 5, so we've got 4 times 5 is 20, times 4 is 80, so we're subtracting 80, which of course therefore is equal to 1. Now, this is where the interpretation part comes into it. Because we've got the discriminant is equal to positive 1, it means that our discriminant is more than 0. Now if you come up all the way to here where you've got our 3 possible solutions, that is where the discriminant is less than 0, the discriminant is 0, or the discriminant is greater than 0, what we can see here, because our number is positive 1, our discriminant is greater than 0. So what that's going to give us is it's going to give us 2 solutions, as you can see. Therefore 0 equals 5x squared minus 9x plus 4 has 2 solutions. And it'll look pretty much something like this, where it comes down and goes through the x-intercept twice. Okay, so for the last 2 questions, what I want you to do is press pause and attempt them. Remember, once you're done, to just press play and check your answers out against mine. Alright, so welcome back once again. What we've got here is we've got our part B, which you've got 0 is equal to 4x squared plus 4x plus 1. And what we need to do is we need to first of all go through and label our a, b and c values. So let's go through. We've got our a value here being 4, our b value here being also 4, and our c value being 1. Now what I've done is I've written out the formula for the discriminant. So I've got discriminant is equal to b squared subtract 4ac, and I've substituted in my b values, my a values, and my c values. So my b of course was 4, my a value was 4, and my c value was 1. So this got us 4 squared is 16, and 4 times 4 is 16 times 1 is 16. So you got 16 minus 16. Now when you get 16 minus 16, you actually get 0. So we know that the discriminant is equal to 0. So we come up here to our solutions, and let's just delete the last one that we circled. So you come up here to our solutions, and we end up seeing that the discriminant is equal to 0. So it's not less than 0, and it's not greater than 0. It's equal to 0, so therefore you're going to have one solution. So we know that our graph is going to look something like this for this equation, where you've got your axis, excuse my wonky axis there, and you're going to come all the way down. It's just going to touch, and then it's going to go back up. So it actually only touches the x-axis once. For part C, you've got 0 is equal to 3x squared plus 2x plus 10. Now what we need to do once again is we go through and label our A, B and C values. So we've got our A, our B and our C values. So that's A is 3, B is positive 2 and C is positive 10. Now once again I've written out the formula for the discriminant. So you've got B squared subtract 4AC. Now our B was 2, our A was 3 and our C was 10. Now 2 squared is 4. 4 times 3 is 12, times 10 is 120. So you get 4 minus 120 gets us negative 116. And because our discriminant is a negative, that is, it's less than 0, we have no solution. So we come up here, we've got discriminant is less than 0, we have no solution. So what you're going to get is you're going to get a graph that looks something like this, where it comes down, doesn't touch the x-axis at all, and goes up.